second video. Okay, thermal mass and thermal inertia. This is very interesting. You don't have to remember this. What you need to remember about that is some material store heat more than other. That's what we mean by thermal mass. We said there are some houses that are completely passive. They're made out of mud or stone. They store a lot of heat during the day, and during the night they emit that heat slowly. So energy absorption and storage, it varies from a value from 1 to 2.6. It increases the R value, and the outside insulation have mass factor of 2.6. Inside insulation have a factor of 1.5. If you want to read more about it, it's in the book. But I just want you to understand the idea when somebody says thermal mass and thermal inertia, it means how much energy that material can absorb. What do you think about stone? Does it absorb heat? Yeah. We have stone ovens, we have pizza stone. Stone absorb a lot of heat, so it has really good thermal mass. Thermal inertia is how long does it take for that material to dispense the heat. Metal is not good because metal will dispense the heat right away. It will cool off quickly. So stone is also have really good thermal energy. It dispense slowly, it absorbs slowly and a lot, and dispense it slowly. So is water. It's good to store heat in the water. Probably you noticed that if you have a gallon of water in your that's hot, of course the bigger the better. It remains hot for a long time. It stores water has really good heat capacity. It stores heat and dispenses it very well. Okay. What is insulation made of? We said minerals, matter that trap air, some kind of fiber. That's why we always have fiber. We're trying to reduce the circulation of air. Plastics, glass fiber, or cellulose, anything that can be fluffy. The fluffiness stops the air from moving around. That's the idea. It will also help if this material is also non-conductive. What's a non-conductive material? Carbon-based, like plastics, wood, shreddings, anything made out of carbon is good insulator. Okay? So if you look at the hoodie over there, it's made out of fluffy material, polyester fibers. Same thing here, very fluffy material. If you look inside, the lining is very kind of velvety. This will trap the air from moving around. Okay? Wall insulation, we have the bats, foil sheet, and non-combustible material. So this is between in the wall. We put our bats in there. Those things are really good to install before the wall is being closed. You put these inside and you get them like in place. Question.
What does it do? Like why you put the bats in there?
Insulation. Good insulation.
It's not. It's the line. I don't know.
So these are the studs in the wall.
Yeah.
And this is from the inside before you put the drywall on it.
Okay.
So this kind of like a blanket that's inside. Instead of putting loose filling, this is a completely sealed blanket. It has plastic on it to a barrier, so the air doesn't go through it, and actually it will keep the place insulated.
So it's not the line thing?
No, that is to hold it in place.
Oh,
Because this is very soft.
I
This is,
get it.
yeah. This is very soft. It's just to hold it in place. Otherwise, it will be mushy. Yeah. And if you put that in the, sometimes they put it in the bottom floor between the basement and the first floor, and they hold it in by twine. You'll see a picture of that as well. Density and weight. So density is the weight divided by the volume. So the weight is density times volume. Volume is how much space that material takes. And volume, again, we did the volume before, which is depth, width, and height, 3D. And that's the conversion. That number is the conversion between inches and feet. Somehow we measure with inches and feet, and 1 foot is 12 inches. So 12 times 12 times 12 is 1,728. Is that true? Let me check. Yep, that's the conversion rate. So this is how you calculate volume. Why do you need to calculate volume and density? I'll tell you why. So once you get the volume, you multiply by the density to get the weight. Because when you buy loose insulation, they sell it to you by weight. And the weight does matter and density does matter when you want to put that material together inside a wall or inside a cavity. That's why when you do the insulation for the attic, you put it in and you let it settle, you come back and you put it in again. I put two nice videos on Blackboard that I wish you would watch about insulation. We'll do that. So this is an example of how to calculate weight. A wall that has 3.5 inches deep, 14.5 inches of width, and 93 inches of height. The cellulose has a density of 3.6 pounds per cubic feet. Find the pounds of insulation that we need. So I want to insulate this wall. This is the cavity. We said 14 inches. And 93. Consistent. So first, I have to find the volume. Equal inches times 17. What was the number? 17, 28. That will give me the volume in feet. And you can write that somewhere and you can look at your note if somebody asks you that. I will not remember that myself. So I got 2.73 foot cube, and cellulose has a density, so the weight, how much do I need? So that gives me 3.6 times 2.73 foot. And I got 9 pounds, 9.83 pounds. So 10 pounds, you go and you buy the insulation.
So that's divided by 1728.
Yeah, just to convert from inches to feet cube. Good. Okay. Other types of insulation. Three types of insulation. These are put between the for masonry and steel and wood building components. You can put it like these ones or these ones. You can put it between cavities. They have high costs, very durable, good for foundation and marine application, and also they are very good for solar collectors. Blown fiberglass and mineral wool, again shredded fiberglass. You go with a machine like a vacuum to blow in that until it settles. Made out of waste, bats, it has lower R value than bats. Why? What would you think? Probably more space, right? More loose, not as dense, not as connected. They are sold in bales. Just go and just put them in there. Require blowing machine with an amputator. There's always issues with the machine. You can stop. Has anybody seen that done before?
No.
Like the blowing installation?
Yes.
Probably you've seen it. I've seen it around in Springfield a lot. So you fluff the material. There's some in the back actually. Maybe you throw it away. They come in big machine. The machine that fluff that cellulose. You know what is cellulose? It's a fancy word for.
So like ripped up jeans and shit.
No. Close enough though. Newspaper. Old newspapers. They belt it together. They spread with the anti-fire or fire retardant, and they sell it as blowing. So it's very, very inexpensive. And this is the density here. Keep this number in mind. It's also in the book in case you need it. And expect settling. You're gonna blow it in the attic. Wait for it for like a week or so to settle. Then you come back and pack it again. More information about blown fiberglass. Should not be more than 1 pound per cubic feet for ceiling and attics. Again, you don't want to overload the ceiling. Not greater than 1.5 pounds per feet cube per wall. You don't have to remember these numbers now, but it's good to know where they are so you can look them up. Look them in the book so you can have an idea. It's so many to remember and they do change. Previous density calculation, same thing. You have to calculate density because you're going to buy them by pound. Mineral wool is denser than fiberglass. It is no longer the dominant insulation. There used to be a time when mineral wool was the top thing in the industry, I think in the 80s or the 90s, but it lost a lot of popularity because we came with the polyethylene, which is really very, very dense and it has good R value and it works better and easier to manufacture. And also these things are really easy to shape. You cut them with a utility knife and you put them in good locations and they don't deteriorate with time. That's something also you want to think about. You don't want R value that reduces with time. What could affect the insulation? Sun, water, vermin. Some of them, if you look at some of the old material, after a few years you go and you touch them and they fall apart in your hand. That's not something you want. This is the blowing insulation. We talked about cellulose, ground up newspapers. They treat it with fire retardant. Good R value is not that bad per inch. The problem is it absorbs more water than wood or fiberglass. So you do not want to put that in a place next to the lake or beach. It will absorb more water and it gain weight doing that, and it will be good environment for bacteria and fungus. Not good for coastal climate. Attic insulation, this is the density that you want, between 1.2 to 1.6 per cubic foot. Expect 15% of settling. Wall insulation is 3.5 to 4 pounds per cubic foot. This is all density. This is how much density you want, because density does change with change the R value. So you want to be in the right density. If it's less dense, then you put less material in there. Vermiculite and the perlite, they are heated dry pellets. They are kind of popcorn, like popcorn. They also provide good insulation, and they are used to fill voids. Again, you never want a place that's just empty airspace. That's bad for insulation. So you're going to fill it with something, and these are actually can be mixed with cement to provide better R value for the cement. The R value. Plastic foam panels like these ones. These are very, very useful. I've seen them being used on duct between rooms with plywood. They do a lot of good insulation. And this one here, just this board is R4. So that is pretty useful. You can buy some of these and put them beside the plywood. And this I think is R8. Question?
So if that was like the bottom one,
Yeah.
that was in a wall, why does it need to be reflective?
You still radiate. even if there's no visible light. The jacket, why the jacket lining is reflective, it's not glowing, but everybody's radiating, even if you don't see it. So you will cut it off with this reflective.
It still matters.
Yeah, yeah.
If it's not the house.
Yeah, even if you buy a nice insulating mug or a thermos, like the Yeti one, you look inside, it's reflective. Try to reduce the radiation. Polyethylene, these are the panels, they come in big panels, and they have machinery that cuts them into grooves and makes shapes out of them. Very useful. They're used for duct work, but not in this area. Why? They cannot stand hot air. They're good for cooling, not for heating. This is how we make duct out of them. So a machine, you put these boards in a machine and it cuts grooves in and you can put them together. It looks very nice, good rigidity, but they have their drawbacks. I haven't seen much of them used in New England, but they're very common in the South when you need a lot of cooling, not heating. So they look like pretty neat, very fast to install, very lightweight. Probably you can install the whole thing in one day. They come pre-cut and laser cut, so it's very useful. But again, I think there are new material now that can withstand the heat and can be good in this area, but I don't know if they pass code or not. I haven't seen them yet. Pros and cons: excellent in tight areas. Good R value between 6 and 7, so you do not have to insulate the duct. Can be used as filling for panels. Can be sandwiched with plastic, steel, or aluminum, like here. Caveats or problems: R value deteriorate with time, depending on the brand and how much money you put on them. I mean, you can see two insulation panels from different brands, and one of them is much cheaper. They look the same, but some of them actually, with time, they react with oxygen and they deteriorate. They are susceptible to UV light, so they cannot be outside or in direct sunlight because eventually they will lose R value, and they're very brittle. They can break. I mean, this thing is going to be a strong, it can break with some lot of force. Mechanical damage, and they're also combustible. So what do you mean by mechanical damage? Somebody can fall on them and they will break. They can't stand a lot of beam. So you want to put them in a place where they actually not touched, nothing can fall on. Foam insulation and injection. This thing is the worst thing ever, in my opinion. It's very bad for the environment. And look at the guy, he's wearing a hazmat suit because this thing is so sticky. Did anybody had to work with it? The foam, the can?
I've done the hand stuff, yeah.
Huh?
I've done the hand stuff and it's horrible.
Yeah.
It's everywhere,
It cannot shape it, it's very nasty, it's hard to work with. Does not insulate very well, but it's good as a quick fix, but I would not put that in a cabinet like this. This is really bad.
Some people do it like it's their art too, they do everything.
Yeah. I don't know, to each his own. Foam. It's a polyurethane with blowing agent like CO2 or HCFC, which is not good for the environment. It has great adhesion. Yeah, good luck trying to get that out of your hand. It's really messy. Good structural strength. I don't know, depending how you spray it. It has air sealing capacity. Good thermal resistance. R6 and 7, which is really good. That's per inch, by the way. Foam has R value of 3.6 per inch, and I don't know. I think this is also per inch. Okay. Facing and barrier. So one thing you have to take from this is those barriers are very required to put in a wall because they have wax in it. So basically the vapor won't go through them. And there are also some fire barriers that have fire-retardant material. So if the wall gets heated or starts catching fire, it will not combust continuously. It's called also craft barrier. There's some aluminum foil involved in it. White vinyl sheeting. There's some in the book. Where do you find them and where they're acquired? Inside the house. If you look here, they're kind of between the walls, between the fittings. It's good to have them as kind of it works kind of like a gasket. And where to install the barrier? So this is the outside. you're gonna have a barrier here to eliminate the water from going all the way here inside. And you want them actually from both sides, inside and out, because in the winter time it's dry outside and humid inside, so you don't want the humidity to go to the wall from the inside, and vice versa. In the summertime the humidity is very high from the outside and the inside is dry, so you get a lot of moisture from the inside when you're actually trying to cool. Retrofitting. These are some of the stuff, some of the places that you want to make sure that you insulate in your house. And this is some of the way where you can pump in insulation to the wall. You put a hole in the bottom in the top, and you keep filling until I mean, I'm sure you've seen those. They do like hole saws inside the wall, and they pump. Yeah, go on. And this is what we talked about before. It's the bats, but now they put them in the ceiling with some insulation, and they hook them up with twine. And this is a good way to insulate the ceiling as well. This is some recommendation for the zones. Okay, the zones, I mean the location. And look at the link, because those things do get updated. If you look at the attic area, we have I think we are in zone 5 and 6, where you want R38 to R60. That's the limit that you want, because we have a lot of heating. Most of the heat will escape from the roof. So walls around 16 to 27, floor 25 to 30, and basement wall framing cavity insulation from 11 to 19, and basement wall from 10 to 15. Bless you. This is some of the location where you want to go and look for insulation. There's a lot of them, but it becomes a really good task when you have to retrofit. So when you go to a house and you have to write down the place to insulate, there's the vents, doors, walls, this area over here, which is always neglected. And actually this area get a lot of negligence here. Nobody pay attention to it because it's sticking out, but it is losing heat. Some new material. Make sure if that's going to be your area of work, you want to get updated with the DOT. They do have some mailing list that tell you what is the new material, what is being banned, what is environmental friendly, and what is not. So let's we can look at that as well. Okay, I think that's all I have for the PowerPoint. Okay, so video.